Here is a question that I'd like you to keep in mind as we go through the contents of this video. The question is, can the MNIST database be used for both supervised and unsupervised learning? Or is it only useful for unsupervised learning?
Hi, and welcome to this module where we'll be using TensorFlow for a simple machine learning algorithm. We'll use the k nearest neighbors algorithm to recognize handwritten digits which are present in the form of images. We'll introduce the MNIST handwritten digit dataset. It's a great dataset to get started with on machine learning and pattern recognition techniques. We'll then understand how the k nearest neighbors machine learning algorithm works before we apply it to this MNIST dataset. And finally, we'll implement the k nearest neighbors algorithm in TensorFlow and use it to identify handwritten digits from 0 to 9, which are part of the MNIST dataset. MNIST contains a large number of images where each image represents a handwritten digit. All these images are pre-processed and well formatted, which means it's very easy for you to use in your machine learning algorithms. MNIST stands for Modified National Institute of Standards and Technology. The MNIST dataset is freely available at Jan LeCun's site. You can see that it has a training set of 60,000 examples and a test set of 10,000 examples, all images with handwritten data. Every image has a label associated with it, which indicates the digit that is represented by that image, 0 through 9. You can see the gzipped files, which contain the training set, the test set, and the corresponding labels right here on screen. We won't be downloading these files from here though. We'll just leave it to a TensorFlow library that will do that for us. This is how the images in the MNIST library look. Each digit is in grayscale, which means it has just a single channel. Every image has a standard size. Every image is of size 28 into 28, 28 pixels width and 28 pixels height, which gives us a total of 784 pixels to represent one image in the MNIST dataset. You can imagine every image as being subdivided into a grid where different cells of the grid hold one pixel value. Every pixel holds a single value for the intensity of that pixel. Remember, this is a single channel image. Let's see how the values for a particular image might be laid out. If you look at the numbers on screen, you can see that the portions where there are strokes of the image have higher intensity values. The white spaces in the image have lower intensity values. The intensity values should give you an idea of what that digit is. So if you kind of look really hard, you can see a 4 right there in that grid representing that image. Each image in the MNIST dataset has a label associated with it, which tells us what digit is represented by that image. So each of these images on screen will have the labels 5041. Using the MNIST dataset is a great way to start off with machine learning and pattern recognition techniques. It's the equivalent of the Hello World program when you start off with programming languages.
Let's return to the question we posed at the start of this video. This statement on screen now is false. The MNIST database can be used for both supervised and unsupervised learning techniques because, as we saw, the MNIST database consists of images of handwritten characters which have been labeled with the actual correct label. Anytime you have a data set or a corpus in which you have data, that is feature vectors, as well as the correct labels, that is a perfectly acceptable data set for supervised learning techniques. You can use those to train your machine learning algorithm. So this statement is false.